Hello everyone and welcome back to my YouTube channel, The Sharpening Guide. You're probably thinking, wait a second, something sounds different. And yes, you're right. I've been working on evolving my setup, and today I'm trying out a new voice. Hopefully it sounds better and helps take this channel to the next level. Today's video is a special one, not only because of the voice, but also because I'm using the TSProf K03 for the very first time in a full-length video. And I didn't just get the standard version. I went all in and picked up the complete all-sharpness kit, also known as the Knife Brothers kit. At some point, I'll swap out the sticker to match my channel's red and black color scheme, and the old sticker plate will eventually be included in a giveaway. But let's talk about the real highlight of today's video. The knife we'll be sharpening. This is the SRM Asika, and it's a very special piece, because I'll be giving it as a birthday gift to a close friend of mine. The knife didn't originally come in this box. I actually bought the presentation case separately and customized it myself. I lined it with foam and blue silk, since blue is his favorite color. You've probably already guessed that's also why I chose this particular knife. It features blue accent details, has a titanium handle for that premium feel, and comes with a distinctive Japanese tanto blade, which fits perfectly, because he's really into Asian culture. That's also why I paired it with a wooden box featuring a yin-yang symbol. I thought it would be the perfect match. Now, finding this exact version of the knife was much more difficult than I expected. It's an older model that still appears in some online stores, but the photos can be misleading. SRM completely changed the knife without telling retailers. They altered the colors, milled out the titanium handle to reduce weight, and even changed the entire blade shape. So what happens is, you think you're buying the original model based on the listing, but what shows up is the updated version. And it's just not the same. I ended up ordering 6 different knives from different shops trying to get the original. I contacted every shop I could find, but none of them had the old version anymore. Luckily, I managed to track one down on eBay just in time. I originally wanted to buy 2, one for him and one for myself, so we'd both have the same knife as kind of a connection. Unfortunately, that didn't work out, but I'm glad I was at least able to get one for him. I really hope he likes it. It would be amazing if you could leave a birthday wish for him in the comments. I know he would appreciate that. The knife uses a 154 cm steel. It's not one of those high-end super steels, but when the heat treatment is done right, it's a solid and reliable performer. That said, if the heat treat is off, sharpening this steel can be an absolute nightmare. Trust me, I could write a whole song about it. But when everything lines up, it actually sharpens quite well. Still, if you're aiming to push it to its full potential, there are definitely some things to keep in mind, especially when it comes to the choice of sharpening stones and your burr removal technique. The steel's composition, combined with how it's processed during manufacturing, can bring a few hidden challenges. And if you're not aware of them, they'll show up during sharpening, whether you like it or not. I almost forgot to mention how perfectly the name of the brand fits today's video. SRM stands for Stay Ready for More, and with a brand new sharpening system and a brand new voice, it really feels like everything is coming together just right. Now, of course, this blade shape doesn't make the job any easier. The Japanese tanto grind is tricky, especially when the secondary tip isn't sharply defined. You really have to be precise not to round it off during sharpening. I'll also show you the factory grind, and especially on one side, there are some pretty serious issues. The bevel is uneven and there are clear inconsistencies in the blade geometry. We probably won't be able to fix everything, but I'll do my best. Before I give the knife away, I'll go through a full maintenance routine one more time because the action on this knife isn't great right now. It runs on bearings, but there's a lot of thick grease inside, which makes it feel slow and sticky. I'll clean that out and re-lubricate it. If you saw one of my recent shorts, you probably recognize this knife already. That video got quite a few views. SRM updated the design to use washers instead of bearings. The new version actually has slightly better action, which you'll see later, but we'll definitely get this one dialed in too. Alright, let's bring you in closer and take a look at everything. I've now equipped the K03 with the L adapters and quick clamps, and roughly pre-positioned everything to figure out the best way to secure the blade. To help compensate for slight unevenness in the geometry, I'm placing a thin piece of leather between the clamp and the blade. The most important thing is making sure that the straight edge of the knife is as parallel as possible to the rotational axis of the system. That's a bit tricky in this setup since my overhead camera is mounted directly above the clamp, so bear with me if things get a little awkward during positioning. I've positioned the knife and the clamps so that the tip points slightly away from the center of the system. More specifically, I've aligned the secondary tip with the rotational axis of the K30. This way, I avoid any clearance issues near the handle during sharpening, and I get a slight angle increase as I move toward the tip. That small change in angle actually helps to keep the bevel width more consistent across the entire edge, even with the tricky blade shape we're dealing with here. As always, I start by coloring both sides of the edge with a red marker. That helps me find the exact sharpening angle by showing where the stone makes contact. We'll now use the 50/40 micron stone to find our sharpening angle, and this stone will also be our finishing stone for today. I'll explain later why I'm using the MS1 stones for this session, instead of my usual alpha stones. As a first step, I always check whether I can reach all the way into the heel of the knife without the stone hitting the handle. You should always test that first before you start sharpening. And in this case, it looks really good on both sides. It's definitely close, but there's just enough clearance, so we're good to go. To start, we'll test an angle of 18 degrees per side, since the presentation side seems to be somewhere in that range. The other side has a noticeably steeper factory angle, so we'll try to balance that out without drastically changing the bevel width or making it look uneven. Setting the angle with the K03 is honestly a lot of fun. It just makes the whole process feel smooth and precise. All right, let's make a few light passes across the edge and watch closely where the marker starts to come off. That will show us exactly how well we're hitting the bevel. I probably don't need to mention it, but with this blade shape, we have to treat both sections of the edge as separate areas during sharpening. Since this isn't a classic American tanto, but rather a continuous flat grind across the blade, there aren't any extreme angle changes between the two sections. That means we can use a single angle setting to sharpen both parts evenly, which makes things a bit easier in this case. With American tanto blades, it's a completely different story. I actually already picked one up for a future video, just to show you how to properly sharpen a true tanto knife. One thing we absolutely want to avoid is running the center of the stone over the secondary tip. That would round it off, and we definitely don't want that. With the 18-degree angle, this side already looks pretty good. We'll fix any smaller inconsistencies during the sharpening process. Now let's take a look at the other side. I'm working extra slowly and carefully here, even more than usual, because I only have one shot to get this right. And since this knife is a gift, I'm being extra cautious to make sure everything turns out as clean as possible. Okay, this side actually doesn't look as bad as I initially feared. The angle here is about 2 degrees steeper, since we're removing material closer to the shoulder of the bevel. But in this case, that's not really a problem, because we're aiming for a flatter angle, around 18 degrees, and judging by the apex, it still looks fairly well-centered. That means we should be able to create the new, shallower angle without ending up with noticeably uneven bevel widths on both sides. Now, if we were trying to preserve the steeper factory angle, we'd need to approach this differently. There are a few useful tricks for balancing bevel width when changing angles, especially if you're trying to achieve a symmetrical look or fix an uneven grind. But I'll save that for a separate video where we can go into more detail. What's important here is to take your time and pay close attention to how the red marker is being removed. Think carefully about what will happen if you continue sharpening with the current angle in clamping position. Every bit of steel you take off is gone for good. And while many mistakes can be corrected with enough time and precision, fixing bigger issues later on can be frustrating and take a lot of effort. I know I've been talking a lot and explaining everything I'm thinking and doing, so thanks for sticking with me. I just hope it's still interesting and that some of these details might help you out one day if you run into a similar issue. But enough theory for now. Let's bring you in closer and finally get started with the sharpening. I'm starting with the 100/80 micron stone to remove material in a controlled and gentle way. One thing we absolutely have to avoid is letting the center of the stone pass over the secondary tip. If that happens, it could completely ruin the shape of the blade. That's exactly why I'm not starting with my coarsest stone. If I made a mistake with something that aggressive, it would show much more clearly and be a lot harder to fix. As you can see, I'm working as carefully and controlled as possible. I'm paying close attention to how the red marker wears off, using it to guide me and find the exact position where I reach the secondary tip just enough to hit it cleanly, but without going too far. I hope the camera angle is working well for you so far. For me, it's actually a bit tricky. The camera is right above my head, which really limits my view. Normally, with something this delicate, I'd have my face about 2 centimeters away from the edge, watching every move like a hawk. But that would make for a pretty terrible video. Just 20 minutes of staring at the back of my head. Nobody wants that. Around the secondary tip, I have to slow down and work even more precisely. The factory grind isn't perfectly aligned in this area, which is pretty common with tanto blades. But we'll fix that as we go. And just in case you notice any slight movement in the knife during sharpening, don't worry. That's not the K03's fault. It's actually my wobbly old table. The silicone mat underneath doesn't help either. The sharpening system itself is rock solid. Zero play in the mechanism. But I can't exactly go out and buy a brand new table just for sharpening. Not yet, at least. For now, I've got some old camera tripods braced under the table, doing their best to keep things steady. Another important point we need to consider with this blade shape is the balance of material removal. It's crucial to spend equal time sharpening both sections of the edge. Otherwise, we risk shifting the position of the secondary tip. If you spend too much time sharpening just the straight section, the secondary tip will gradually move to the left. So the goal is to remove material as evenly as possible across all four sections of the blade, both areas on both sides, so that the secondary tip lines up correctly at the apex when viewed from both sides. On this particular knife, the secondary tip sits slightly farther back on the show side, so I'm adjusting that by carefully removing just a bit more material in the right places, trying to bring it into better alignment with the other side, at least as much as the geometry allows. At this point in the video, I want to explain something that might help many of you improve your own sharpening results. Specifically, why I chose to use the MS1 stones for this knife made from 154 cm steel, instead of my alpha stones, which I usually prefer when working with high-performance steels. To understand that decision, let's first take a closer look at the steel itself. 154 cm is essentially an upgraded version of 440C. It's a well-balanced stainless steel with good edge retention, decent corrosion resistance, and a respectable level of toughness. What makes the biggest difference during sharpening are the key alloying elements. It contains around 1.05% carbon, which gives the steel its hardness. There's also about 14% chromium. That's what makes the steel stainless. But more importantly, it forms large chromium carbides. These carbides are extremely hard, and they heavily influence how the steel interacts with sharpening abrasives. The steel also includes roughly 4% molybdenum, which increases toughness, refines the grain structure, and improves wear resistance. And importantly, it contains no vanadium, which means the carbide structure is simpler and not quite as wear-resistant as vanadium-based steels. But in return, it's easier to sharpen with the right approach. Now let's talk about stone selection. And here's a simple rule that I always keep in mind. Harder bonded stones work best on softer steels, and softer bonded stones are ideal for harder steels. At first, that might sound a bit strange, but it makes perfect sense once you understand how the interaction works. Softer steels like this one, typically in the 59 to 60 HRC range, create much less wear on the sharpening stone compared to very hard high carbide steels. But that doesn't mean they're always easier to sharpen. In fact, because the steel is softer overall, the diamond particles tend to cut deeper into the material. That added penetration increases friction, which puts more stress on the bond that holds the abrasive particles in place. If the stone's bond is too soft, this added resistance can cause the diamonds to break free too early or shift slightly in the matrix. And that leads to uneven feedback, a less consistent scratch pattern, and faster stone wear, even though the steel itself isn't particularly hard. That's exactly why I prefer a harder metal bond in cases like this. In the MS1 stones, the diamonds are held very securely, which allows the abrasive surface to resist wear and maintain its shape over a longer period of time. That's especially important when working with steels like 154 cm, where the heat treatment and alloy structure can create micro variations in hardness along the edge. If your sharpening surface begins to wear unevenly, those small differences in steel hardness become even more noticeable under the microscope, leading to an inconsistent scratch pattern and an uneven bevel geometry. By using a hard-bonded stone that stays flat and cuts uniformly, I can reduce those effects and create a more consistent and refined edge. This also helps minimize stone wear and ensures the stone stays flat for longer. In other words, I get cleaner material removal and a much more uniform scratch pattern, which is exactly what I want, especially when working on a steel with slightly uneven carbide distribution like 154 cm. Now, could I use the alpha stones for this job? Absolutely. They're excellent stones, and they'll sharpen 154 cm without any issue. But the alpha stones are resin bonded and designed to continuously release fresh diamond particles as you work. This makes them ideal for steels that are extremely hard, typically above 62 or 63 HRC, or steels with a high content of ultra-hard carbides, such as vanadium or tungsten carbides. In those cases, a softer bond helps prevent glazing and keeps the stone cutting efficiently by constantly exposing new abrasive material. And thanks to the special formulation of the alpha bond, they remove steel very efficiently, but also in a surprisingly gentle and controlled way. That's why they're my go-to choice for high carbide, high hardness steels, where both cutting speed and surface refinement matter. But for a steel like this, that quick abrasive release is not only unnecessary, it can also be inefficient. It would wear down the stone faster than needed and leave me with a more polished finish than I'm actually aiming for. In this case, I'm going for a functional working edge, around the 500 to 600 grit range. Something that's crisp, with some micro-tooth structure, left for better cutting performance in real-world use. And that's where the MS1 stones really shine. They're perfect for creating a controlled, balanced finish, especially when dealing with tricky areas like the secondary tip of a tanto blade, where every degree of angle discipline makes a difference. So, in short, using the MS1 stones on 154 cm lets me work more efficiently with better control and lower stone wear. And the results speak for themselves. As always, we're talking about very fine details here. Things that go pretty deep, but in the end, they're often what makes the difference between a good result and true perfection. I've built up a pretty wide range of sharpening stones over time, and honestly, you haven't even seen all of them in my videos yet. But to put it simply, I just try to use the right tool for the job. That doesn't mean you need to go out and buy as many stones as I have. Work with what you have available, and if the time ever comes when you feel ready for an upgrade, I'll be more than happy to help you out. And of course, those of you who already have more experience probably have all the gear you need, or you already know exactly what matters most when it comes to choosing the right setup. You've probably noticed that I'm checking the edge more frequently than usual in this video. And that's absolutely intentional. With a blade like this, especially around the secondary tip, it's crucial to make sure you're forming a clean, consistent burr across the entire cutting edge before moving on. That area is especially sensitive, and even a small mistake can affect the final symmetry of the bevel. My recommendation: take your time and check more often rather than not enough. Ideally, you want to reach the point where just 1 or 2 light strokes with the sharpening stone are enough to feel a burr on the opposite side, from heel to tip. Only then should you move on to the next grit. In today's progression, we'll finish with the 50/40 micron stone. Now, based on the numbers alone, you might think this falls somewhere around the 400 grit range. But that's not the full picture. High-quality Russian diamond stones like the MS1 series are known for their extremely tight particle distribution. That means there's far less variation in diamond grain size, fewer oversized or undersized particles, which leads to a cleaner, more uniform scratch pattern. So while a 50/40 micron stone might technically align with a 400 grit finish, in practice the results are more comparable to what you'd expect from a 500 to 600 grit diamond stone. The edge it leaves is crisp and toothy, but without the uneven coarseness that's common with standard diamond plates in that range. And there's another important factor to consider. When comparing grit to micron, especially across different manufacturers or bonding types, numbers alone won't tell you the full story. Even if 2 stones have the same micron rating, the bonding type can still make a noticeable difference in the scratch pattern. A softer bond cuts differently than a harder bond. So in practice, the finish may look finer or coarser, depending on how the abrasive is held in the stone. In short, don't rely only on the grit number or micron label. Learn how your stones behave under real sharpening conditions. Use your eyes, your fingertips, and, if you have one, a microscope. The scratch pattern you see is what truly defines your edge, not just the label on the stone. All right, let's get back to what really matters: the sharpening process itself. And yes, I know I've been diving into a few side topics throughout the video, but that's just how it goes sometimes. When something important pops into my head, I want to share it while it's relevant. Still, I'll try to keep things a bit more structured next time. Thanks for sticking with me this far. Before starting burr removal, I like to make a few consistent strokes on all sides of the blade. This helps smooth out any minor inconsistencies and ensures that I'm truly ready for removing the burr. Now, when working with steels like 154 cm, especially with a coarse finish, burr removal can be a bit challenging. In my experience, the ease of this step often depends heavily on the heat treatment of the steel. But don't let that discourage you. With the right technique, it's absolutely manageable. Here's my preferred method. First, I gently flip the burr back and forth using light, alternating edge-trailing strokes. This weakens the burr and often removes portions of it immediately. If you were to look closely under a microscope, you'd notice that in harder carbide-rich areas, the burr tends to break off more easily. Meanwhile, in the softer matrix areas, it can stubbornly cling on a bit longer. So don't be surprised if your burr removal feels somewhat inconsistent. That's totally normal for steels like this. Once I've flipped the burr back and forth and feel I've removed as much as possible, I proceed with a few very gentle, careful edge-leading strokes. This further reduces any remaining burr. Be especially cautious here. Using a coarse stone too aggressively at this stage can easily tear off the burr rather than cleanly removing it, which isn't ideal. The most important thing is continuously checking your progress. Once the burr is completely gone, stop immediately. Continuing past this point will only create a new burr. Personally, I prefer reducing the burr as much as possible with the stone and then removing the last traces during stropping. Of course, you can also switch to a much finer stone for deburring. Often this can be easier and quicker. Don't worry about losing your coarse finish. The jump in grit levels typically won't significantly alter your initial finish, as long as you don't spend too much time on it. Feel free to experiment to see what works best for you. Initially, I like to write down every detail from grit finishes to deburring methods and stropping techniques. This allowed me to compare results and find the most effective method. Now I've reached the point where I notice no further progress in burr reduction, so let's move on to stropping. Before starting though, I always check the sharpening angle again, especially since the first sharpening of a knife typically involves removing a bit more material. We're not talking about a huge amount, but just enough to ensure we've reached the good steel. As a result, the final sharpening angle usually ends up slightly higher due to the reduced distance to the rotation axis. This step is crucial because it sets the foundation for our stropping angle. And by the way, the built-in axe cube in the stone holder of the K03 system really makes this part enjoyable and precise. Since I've modified the surface of this leather strop by removing its softer top layer, I'm only lowering my stropping angle by about 0.1 degrees today. As always, I'm stropping each of the 4 sections of the blade separately, applying zero pressure and continuously checking my progress as I go. Today I'm using a leather strop loaded with 6-micron diamond paste. Honestly, I'm not entirely convinced about the quality of this paste, but I didn't have a better option readily available. Ideally, for this steel and finish, I'd prefer using a 12 or 9-micron diamond emulsion, but I'll need to restock on those soon. Sometimes I give away or sell my supplies too impulsively, and it takes a while to get replacements or find new products to test. The simple rotation mechanism of the K03 really speeds up the stropping process. It's incredibly quick and satisfying to flip the knife over, and honestly, it just makes me happy. I haven't even really talked about all the advantages of the K03 over the Kadet Pro yet, but I'll definitely cover that in more detail in a future video. Maybe even do a direct comparison if that's something you'd like to see. Before filming this video, I actually sharpened a few knives to get more familiar with the system and make sure everything runs smoothly on camera. And I have to say I'm loving the K03. It's all those subtle little details that really make a difference and have completely won me over. That said, it doesn't mean I'll stop using my Kadet in future videos. And whether the upgrade is worth it for everyone, that's a topic we'll definitely discuss another time. And by the way, there might already be some new sharpening stones waiting behind the scenes, especially chosen for testing on the K03. But don't worry, I made sure to pick versions that work across multiple systems, just to keep everyone happy. If you've made it this far, I'm guessing you've enjoyed the video enough to at least consider subscribing and liking. Honestly, I'm curious how many of you have stuck around to this point. So, besides all those birthday wishes for my friend, let me know in the comments if you made it this far. Extra points if you mention how you're celebrating. So now I'm happy with the results, and we can finally remove the knife from the clamp. I'll give it a quick pass on my hanging leather strop as always, and then we'll see each other again in a moment for the final reveal and some cutting tests. Alright, let's take a look at the final result together. Visually, I'm very happy with the show side of the blade. What I tried to show you earlier, though, it's now even more visible. Due to the slightly shallower angle on the other side, are the irregularities in the blade's thickness. I hope you can see it clearly on camera. In those areas where the light breaks in a circular pattern, that's exactly where the blade is a bit thicker. You can even feel those spots easily with your fingers. Naturally, these inconsistencies cause the wavy pattern along the bevel shoulder. To be honest, I'm not sure how something like this even happens during production. If any of you know more about that, Please let me know in the comments. I'd really appreciate it. Anyway, let's see how sharp the knife turned out. I'd say that looks pretty solid. Though, to be fair, I think the other model had slightly better heat treatment. The burr on that one came off a bit more easily, and it felt just a touch sharper overall. But honestly, that's nitpicking at a high level. I really hope my friend enjoys this knife, and of course, the video and all your birthday wishes in the comments too. Also, let me know what you think of the camera angle in this video. Do you prefer being closer to the edge and the action, or do you like seeing more of the K03 in the frame while I'm sharpening? I'm happy to adjust based on your feedback. Thanks to your suggestions in the comments of my last video, I've decided to sharpen my Civivi Buster with Nitro V steel next time. In my opinion, that steel along with 14C28N is one of the best budget steels out there. Although honestly, calling it a budget steel feels kind of wrong. It's almost an insult considering how good it really is. It's possible that I'll feature a different knife first. I've got something special arriving soon, but we'll see how it plays out. Alright, this one is going back into its box, safe and ready to be gifted. Thanks so much for watching. If you enjoyed the video, I'd really appreciate a like, a comment, and of course, a subscribe. Get ready for the next video. See you next time.